Hey guys, this is Mitch with Fine Point CGI, and today we're going to talk about how to make a basic first-person horror character controller inside of Godot. So we're going to go through the process of creating our character controller. We're going to go through and change up our inputs to WASD. We're going to set up the ability to crouch and to uncrouch, and we're going to go through and add a flashlight. So that's what I have in store for you guys today. So let's go ahead and get started. All right. So the first thing we have to do is we need to organize our project. So basically, the reason why we need to keep our project organized is if we don't actually organize our project, it is going to completely become unmaintainable in the future. So what we'll do is we'll right click on our RES, we'll create a new folder, and we will call it scenes. And then we're going to right click, add in another new folder, and we'll call it materials. Because this is a 3D game, so we're going to need materials. And I know that there's going to be some hot button issues when it comes to textures versus materials and whether or not you should have a separate folder for them. And in my personal opinion, I like to have my materials next to my textures, but it's dealer's choice. You guys can do it however you would like. The next big folder that we're going to add is our levels. And then we're going to right click and add one more, and it is going to be models. And the last one that we're going to add is our scripts. Now, I know what you might be asking yourself. What's the difference between levels and scenes? So a level is the overall level that the character's in. So it's going to be actually the entire level. A scene is all of the small assets and stuff like that. And really, we could create another folder called assets if we wanted to, and we might need to do that in the future. But right now, we'll just keep it like this. But basically, scenes make up our levels and our models make up our scenes. So that's kind of how we're going to go with our architecture here. But now that we have that, let's create our character controller. So let's go ahead and make a 3D scene here, and let's right click our node 3D, change its type to character body 3D. Let's right click it, rename it, and name it player. And then let's right click it again and add in a child node. Let's add in a mesh node. So we'll add in a mesh instance, and we're going to make that into a capsule mesh. And we'll move this guy up just like that. And that should be about right-ish. And then we'll right-click, add a child node, add in a collision shape. And then we'll come over here and we will add in a capsule shape. We'll drag this guy up like so. There we go. And then finally, we're going to right-click and add in our camera. And we're going to want to make our camera just about in this general location, so that way the user has some way of seeing the scene. So I know I was going pretty quick there, so let's take a step back and let's talk for a second. So first, we added in a character body, okay? And that's a new node, kind of. Basically, this node used to be called the kinematic body inside of Godot 3.5. They renamed it to character body to help give you a better understanding of what it is. So basically, it's just a renamed kinematic body. And as a matter of fact, if you right click and add a child node and type kinematic, you'll see that nothing comes up when you type kin. So it's not here anymore. So it is completely removed. Okay. And you'll also notice that we added in a mesh, and this is where our mesh will be. So we could either make it not a pill, we could make it something like a character body or something like that, like an actual character. But in our case, we're just going to make it a pill for right now. And then when we build our character or something like that, we can add in the actual character and their animations and things like that. We added in some collision because every character has to have collisions. And we added in a camera 3D. So that way we actually have, a way to see our scene. Simple enough, right? So now we need to create our script so we can move around. And actually, Godot makes this really easy. So if we right click our player and attach a script, you will see that first it's going to default to GD script. Let's move that down to C#. And you'll see that we have a template. And templates is something that's new inside of Godot. It's basically a way for you to build code and then reuse it on creation of a script. So think of it kind of like if you've built a basic character movement script or a bullet script or something like that, you can basically just say, attach the script to this guy and run from this basic, base class almost. So we'll call it player, and then we'll hit create. And And in my case, I think it might boot up Visual Studio. Yep, because I had Visual Studio as my default because I was doing my tutorial on setting up C#. So this was set as my default, and that's fine. I can code inside either Visual Studio or VS Code. And let me know in the comments if there's a specific program you guys want me to code in, because I can do either. It doesn't really bother me one way or the other. But you will notice that we have an entire script built for us. So that's really cool. So if we head back to Godot here and we hit Control S and we save this as player under scenes right here. And then in levels, we right click and we create a new scene, and let's just call it test level, and let's name it a 3D scene, and we will click OK. And you'll see that we have a test level. We'll right click that, add in a child node, and we're going to add in a CSG box. And a CSG box is basically a level BSP object. So think of it kind of like an object that you can use to kind of box out your levels and things like that. When we go through level design in the future, you guys will see an entire episode or couple episodes or couple tutorials on gray boxing and level design and things like that. So look forward to that. But for right now, we're just going to pull this guy out about yay big and kind of drag him down like that. And then we're going to go into our scenes and we're going to drag our player into our level like that. And you can see that we have to make this level much larger. So we'll just kind of bring it to about there. And now if we hit Control S and we play and we select current, and you'll see it's going to build our project, you will see we fall through the world. Now, why is that? That's because the CSG object doesn't have collision by default, but we can enable it by coming over here to our use collision. So if you click on that and you make sure you have your CSG box selected, you can just add collision just like that. It's nice and simple. So we'll drag this guy up a tiny bit, hit play, and bam, there you go. And now if we hit WASD, you'll see nothing's going on. And the reason why is because the default character controller inside of Godot uses the arrow keys to move. But you can see we can use the arrow keys to move, and if we hit space, we can jump. Awesome. So a lot of our code is already built for us, which saves us a boatload of time. So since that code's been built for us, really all we need to do is change our controls to WASD. We need to add in crouching, we need to add in a flashlight, and we need to add in the ability to move our camera. So let's basically run down the list. Let's make our camera movable first, and then we'll make WASD movement. I think that'll be easiest, and then we'll grab the other two later. So we'll come back to our script, and let's go ahead and code our camera movement. Now, camera movement inside of Godot is actually pretty simple. Godot has an entire thing built around getting your user inputs. They have an actual function that you can override. So we'll come down here and say public override void underscore input event, okay? And we need to basically check if our event is the proper event type. The thing about events is this function fires every single time you do anything with your keyboard or mouse. So you want to be careful not to have too many of these. That's why I'm only doing it for the character controller and not for everything else, because it's a really heavy function to use. So you want to be careful. But in our case, since the mouse movement is extremely important, we'll basically just allow for that. So we'll say if our event at event, it has to be at event because our at event is right here. At event is a input event mouse motion like that. Now, when we do our character camera movement, we need to basically set our rotation, okay? Because when we move our mouse left to right, we want the character to rotate right, left to right. So we need to set our rotation. So we'll say rotation.y is equal to new vector 3, and we need to put a vector 3 in here. Now, when we do our rotation, it needs to be an x, y, and z value, right? Now, we only really want to set our y value, because when you rotate your object, if we go back to Godot, you will see that when we click on our player, you can see that green axis here is the one that controls our character's movement. And if you look up here, you can see that that's the y axis. So that's how you can know if it's the X, Y, or Z axes that you want to rotate your player on. So if we go back to Visual Studio, and for some reason I have rotation Y, so we'll get rid of that, but we basically want to rotate on our Y axis. So we'll set our stuff equal to rotation.x comma rotation.y minus, and we need to actually pull back our event relative position. So we'll say at event dot rel for relative, and you'll see that it's not here. So now you're probably like, why isn't it here, right? It's the correct thing, but it's not, doesn't show up what we need. That's because C# is a very typed language. So we actually need to cast this as a proper type. So come in here and say input event mouse motion. Motion is equal to at event dot as input event mouse motion. And that will allow us to pull back that specific event. So we'll say motion dot relative dot x divided by 1000 space multiplied by, and we need to multiply it by some kind of sensitivity, okay? Because right now we're dividing it by 1000 because the relative x from 2D space to 3D space is about 1000, I guess, units difference, if that makes sense. So if you divide it by 1000, it just kind of makes it so it's, 1-to-1 instead of, some crazy number. But we need to multiply it by some kind of sensitivity. So if we scroll up here to the top, let's just say public const float sensitivity is equal to 3.0f, and that will work for us. And we'll just grab our sensitivity. We'll come down here and multiply that by sensitivity, and then we'll just grab rotation.z, just like that. And now all we need to do is we need to rotate our character along the x-axis, right? To make it so that they can, rotate up and down, okay? But here's the thing. If you rotate your character on the x-axis, what's going to happen is it's going to do this. Or I guess in this case on the x-axis red, so it would be this. We don't want that, right? So instead, let's rotate our camera, because if we rotate our camera on the x-axis, it's up and down just like this, and that's pretty much what we're looking for. Now, if we were to rotate our camera on our y-axis instead of our character, we could do that, but if our character has a model, it's going to completely break everything. So it's probably not a good idea. Plus, any elements like a lantern or anything like that, if it's not hooked up to the character, it's going to be really funky, because then the head will rotate, but the object won't, and it can be real funky. So that's why we're splitting these two up, if that makes sense. So if we come back to Visual Studio, we can basically just say get node camera, and we'll cast it as a camera, and I believe it's 3D nowadays. Let's see, camera 3D, that's correct, without the capital D. There we go. Dot rotation.x is equal to a new vector 3, much like we did earlier, and we want it to only affect the x-axis, not the y-axis. So we can just say motion.relative dot y divided by 1000 multiplied by sensitivity. And we still need to do our rotation x minus, like our one up here. So we can just say rotation dot y minus this whole value here, comma, and we need to set our other values. So rotation dot y, comma, rotation dot z. And there we go. And that should basically do it for us. So now if we head back to Godot and we hit play, there we go. It's a little on the funky side. Let me see what's going on. So I think we made a mistake somewhere. Let's take a look at our code real quick. Rotation X, rotation Y instead of rotation Y. No, that'd be relative Y. We want rotation X instead. I think that's what I made, where I made my mistake. Let's try that and let's see. That's my fault. So if we do down and up, it's not really working. If we do left and right, that's working. But up and down, it's not happy with us. So let's take a look at it. Oh, I know what's going on. Okay, I'm foolish. So here's the reason why it's broken. let's grab our camera 3D here, and instead let's go with camera 3D camera is equal to, and get this node here. And I'll explain why I am dumb in a second, and I cannot believe I made this mistake. But we'll just paste this guy in here, and in here we'll say camera dot rotation X, motion relative Y, and then camera dot Y and rotation camera dot Z. Basically, what we are doing is we are grabbing our character's rotation and then setting it based off of that. And that's going to cause a lot of problems. So that's my fault. I should have not made that mistake, but that's all right. We'll hit play and let's see if that works. So we can look down, we can look up, we can look left, and we can look right. Awesome. So now one of the big struggles that we're running into is, as you can see, as soon as our mouse leaves the box, our character stops moving. Now that's a big problem, and we can fix that really easily. So Godot has this thing called a mouse capture, and it allows you to actually capture your person's mouse, right? Your player's mouse. It allows us to capture your player's mouse. So basically what we'll do is we'll head back to our horror game, and we'll scroll up to the top, and we'll basically say on ready, let's capture our user's mouse. So we'll say public override void underscore ready, and we'll just change our mouse capture method. So we'll say input dot mouse mode is equal to input mouse mode enum captured. And that'll basically solve that problem for us. So if we head over here and we hit play, it'll capture our mouse and we're good to go. Awesome. Now you will notice if you keep going up like this, you can see now we're upside down. And if we go down, you'll see that we're back to right side up. So we could basically just flip ourselves around, which is a pretty large problem. And also you'll notice that we can't escape from our game. So how do we escape? If we hit Alt F4, we're good to go. So I'll leave it to you guys to figure out how to do that. But basically what I would do is I would just check for an input of you hitting like a button and then stop capturing the user's mouse. And then that allows them to escape out of the situation. And I can show you guys how to do that in the next tutorial if you guys want. But I mean, it's a pretty simple thing. So just basically set up an input and then go from there. And we'll go over inputs in a second. So let's go back to Visual Studio. And you can see we're capturing our mouse mode now. So what we need to do to stop our player from being able to rotate upside down is we need to clamp their value. So if we come to our rotation here, when we do our camera rotation right here, we need to clamp this value so that it doesn't go past a specific value. So what we can do is we can come in here and say mathf.clamp, and we can pass in our value, which is this guy here, comma, our min value, which will be -2, and our max value, which will be 2. And that'll basically handle it for us. So now if we go back to Godot and we hit play, if we look up, we can no longer go and flip our character. You can see that I can just kind of go up and down and it doesn't actually cause any problems. Awesome. So now that we have that, let's set up our WASD movement. And that should be really quick and easy. So if we come up to our project settings, and we come into our input map here, let's add our actions. So we'll say move forward. And if you hit enter, you can just kind of keep adding them. So move backward, move left, move right, interact, flash light, crouch. And those will basically be all of our interactions. So if we come to move forward, if we click the plus icon, you'll see it's listening for an input. So if we just hit W, you'll see it picks up that input. So now we just kind of run through them. Move backwards is S, move left is A, move right is D, interact would be on most games is E, and flashlight generally is F, and crouch is control because we all know control for crouch is better than C. You can fight me in the comments, and we'll click close. And that'll basically be all of our inputs. So now we have to hook them up. So let's go back to our script here and let's come down here to where we're pulling our different vectors right here. And we'll just basically change this from UI left to move left, UI right to move right, UI up to move forward, and UI down to move backward. And there we go. So now if we hit play, you'll see we can use WASD to move around. Except for it looks like W is not working. So my guess is I did not spell forward correctly in one of our sections here. So let's take a look. And I misspelled it right here. So FORWARD, and that will work. And let's double check our code to make sure I spelled it right. FORWARD. Yep. So that should work. So if we hit play, now we can move forward, backwards, and side to side. Awesome. Now I know I'm going pretty quick. So if you guys feel like I'm going too fast, let me know in the comments and I'll slow down. But now we're going to go ahead and create crouching, okay? Because I believe that's the next thing on our list. So we have our movement, we have our camera control, we are locking our mouse cursor. So now we need to be able to crouch. And the easiest way to create a crouch is to use an animation player. So we're going to come back to Godot here. And what we'll do is we'll right click our player, add in a child node, and add in an animation player. And an animation player node is basically allows us to animate anything inside of Godot. So anything that exists, we can animate it with this animation player node. So what we'll do is we'll click on this animation, we'll click new, and what we'll create is a crouch animation, okay? And all we'll do is we'll come up to our camera and we'll come over here to our transform and we'll click this little key button right here. Okay, and you'll see it's going to pop up and say, hey, you want to create a new track for property, position, and insert key? And yes, we do. And we also want to use Bezier curves. Bezier curves gives us more flexibility in the future. Now, granted, in this specific case, we probably don't need it, but it's always a good idea to just use Bezier curves. That gives you a lot of flexibility. So we'll hit create, and then we'll drag this out to 1, and we'll drag this guy down to something like, 0.97, 0.98, somewhere in there. And we'll hit keyframe right there, and you'll see, there we go. Simple enough, right? Now, you can see when we bring this down, it just kind of snaps down to the bottom, and you kind of want that squash and stretch. So let's pull this back a little bit, and let's basically grab our camera and just kind of pull it down to something like 0.94 or 0.95. We'll put a keyframe right here, and that'll give us a little bit of a squash and stretch. You can see it's like a half of a centimeter, and that'll help create a better feeling to it, if that makes sense. So now we need to uncrouch. So if we come here, we click on our animation, click new, and type uncrouch. There we go. We can drag over to 0. We can say, okay, we're going to start at our bottom. So if we go to crouch and we drag this guy down, go to uncrouch, and then set a keyframe right here like that. So it's perfectly in our spot. And then we'll go back to our crouch, go to our first keyframe. Let's right click our position, copy the property, go to uncrouch, go back to the last keyframe location, and right click and paste property and put a keyframe right there. And you'll see that now our character can go up. And then we could basically just come in here and pull this up just a touch more than what we were expecting. You'll see it kind of comes to a rest. And it might not seem like it's a lot, but it's just a slight adjustment to your height, and that can really help bring this together. So now if we go to our player, we come down here, we can basically just add an input for that. So we can come in here and just say, if input dot is action pressed, and the action that we're going to be pressing is crouched. So crouch, and we will need to do some checking here, because one of the big struggles that we're going to run into is if we hit our crouch button, we don't necessarily want to play our animation always, because if we're holding down that action, the animation will continuously play over and over and over and over, right? And we don't really want that. So what we'll do is we'll scroll up to the top and we'll add in a Boolean, and it will be called is crouch. So we'll say public bool is crouched. And we'll come back down here and just say if we are not crouched, is crouched. So if not crouched, then we'll get our node and we'll need to cast it as an animation player, and we'll grab our animation player. So animation, and we will go ahead and play our crouch animation just like that. And then we need to make sure we set is crouched is equal to true. And that will basically allow us that once we've crouched, it doesn't play that animation again. This also can come in a handy when we're doing our stealth elements. We can actually check to see if our character is crouched. So if they're in stealth or if they're not, things like that. So it could be really useful to have that Boolean. Now, you might think, hey, well, we'll check if not else, then we'll stand up, right? But unfortunately, that doesn't work because, you obviously if we're holding down the key, then we don't want us to crouch and uncrouch constantly, right? So only when we let off of the button do we want to uncrouch. So we'll say else. If we have released our button, then we can actually just uncrouch, right? But we also need to check if we're crouched. So we'll say if is crouched, then we can basically just grab this bit of code here, paste it, and say uncrouch. Now, something else that we need to do is when you're crouched and you're moving, you need to slow down. And down here, we're setting our speed right here, which is set by a constant up here, right? So what we can do is we can basically duplicate this constant and just say crouched speed. And let's set that to something like 2, okay? And we'll need to override this value here with something else. So let's come up here and say float speed is equal to speed, and that will allow us to set our speed somewhere else, right? So we can come down here and we can just say speed is equal to crouched speed, just like that. And then we can come into here and just paste this guy like that, and that will override our speed all the way down. So now our character will only move by 2 units of speed versus moving by 5 units of speed. And we might want to adjust our 5 down to something like a 3 or something like that, a little bit slower because this is a horror game, but we'll get to that when we get to that. So now we should be able to test this, and also we need to set this to false because we are no longer crouched. There we go. And now I think we can test this and we should be good to go. So let's head back to our player and let's hit play. And then if we hit control, our character crouches and they move nice and slow. If we let off of control, they speed right back up. Perfect. That's exactly what we wanted. But something that you'll notice is if we go back to our test level and we right click and add in a child node and we add in a CSG box and we make it about this big and we kind of drag it up to about here-ish, I think that will do, give or take. If we turn on collision and we actually hit play, and then we come up to the object, you'll see that we can't go, we can't obviously go through the object because we have collision. If we hit control, we should be able to go through the object, but we can't. And that's because our collision mesh itself hasn't been changed in size. So we need to do that. Now, one of the things that you want to do with creating collision is you don't want to just change your collision size because that's going to completely brick Godot's collision system. So you want to basically change your collision shape by just hiding and showing your collision shape, if that makes sense. So you can disable it and enable it. So let's duplicate our collision shape. Let's name our first collision shape our uncrouched collision shape. And honestly, we might want to just call it standing. I think that might be a better name for it. Let's just call it standing. Like that. And then we'll call this crouched collision shape. And then let's right click and make it unique. And the reason why is because these two guys can share a reference and that will break everything if you don't make it unique. So let's drag this guy down like this. And then let's drag this guy down here like that. And then in our animation player, we can just come to our standing collision shape and we can come here when we are not crouched and disable it, or set it to enabled, I guess. Technically, I think this should be called enabled, not disabled, but that's okay. And then we can come to something like 0.7 or something, and then disable it like that. And then we can go to our uncrouched, and we can do the exact same thing, but the opposite. So disabled, and then come to something like 0.7, and then enable it. There we go. So now if we hit play and we crouch, we can now go underneath our object. But if we uncrouch, we'll go through our object. So that's a problem. So what we have to do is we have to detect if there's an object above us. Let's hit Alt F4 and come back to our code. So what we need to do to stop ourselves from going uncrouching when the user lets go of the control button is we need a raycast up to determine if our player has an object above them. Now, I know that you could come in here and you could right click and add in a raycast node, and they actually have a really nice raycast 3D node. I prefer to use code when I do this because I live inside of the code most of the time when I'm doing my stuff, and debugging wise, it's a lot easier for me to understand what's going on when I have code. But if you feel like using the raycast 3D, a lot of this code will translate. You just have to basically just say .raycast and you should be good to go. But in our case, we're going to use code. So let's go back to the code and let's scroll down here and say, if we are crouched, then we want to raycast. Now, to raycast, you need to get your world 3D and you need to get your direct space state. And that's kind of like the overall space, I guess, state in the space realm of the world, right? I don't know how to explain it very well. But basically, we can say var space state is equal to get world 3D dot direct space state, and it will pass back a physics space state. See this? A physics direct space state 3D. So you could make this a physics direct space state 3D if you want to. It's up to you if you want to type your stuff really, really well or not. It's totally up to you. And then we need to do our raycast. So we'll say var result is equal to space state dot intersect ray, and we need to pass in a physics raycast query. So we'll say new physics raycast query parameters 3D. And weirdly enough, they don't actually have a constructor for this. So instead, we're going to have to do an override kind of method. And this is something that's specific to C#. But basically, we'll just put these little brackets in here, and then we'll be able to type out our stuff. So from equals position. So we're going to say from our position to, and this is where things are going to get interesting. So to a new vector 3, and we're going to do position dot x comma position dot y plus 2 comma position dot z, and then we just have to say comma, and we need to exclude stuff, okay? Because we have collision on ourselves. So if we don't exclude our own collision, then what'll happen is it's going to shoot up and hit itself, and then you'll never be able to uncrouch. So we'll say exclude equals new Godot.collections.array, and then much like how we did here, we actually have to do our own, override here. So this, and there we go. And then we have to check what our results are. So if our results dot count is less than or equal to 0, then we can go ahead and uncrouch. Just like that. And now, if everything's done correctly, if we go back to Godot here, and we hit play, and if we hit control, we crouch underneath this object, and we let off control, there we go. We did not uncrouch. And then if we go past the object, you'll see that we now actually uncrouch. Awesome. So now that we have this, let's set up our flashlight. Now our flashlight is going to be very similar to our actual crouching. So what we'll do is, much like the animation player, we're just going to right click, add in a child node, and add in a light, and we'll add in a omni light in our case because we're going to have a lantern, not a flashlight. Though if you want a flashlight, we could totally do that as well, but I'd like to use a lantern. So we'll do a lantern and we'll kind of drag this guy up. I don't know, somewhere here. This is about where somebody would be holding a lantern, right? And we'll kind of pull this guy over like that. There we go. And then what we'll do is we'll come into our animation player, and just like our crouching animations, right? We could just add in a new animation and call it flashlight. And we need to make our hide flashlight, right? So we'll call this one flashlight hide. And what we'll do is I'll start with flashlight hide because it's going to be a little bit easier. But what we'll do is we'll come into our transform, we'll put a keyframe, and we're going to use our Bezier curves. We'll drag this guy to about 1 second, and we'll put it down here, and we'll put a keyframe. So basically, we put it away, right? Well, when you put away a flashlight or some kind of lantern, right, you need to extinguish it, right? So what we'll do is we'll come to our light, we'll put a keyframe here, and then we'll come to here, and then we'll set our energy to 0. Now, it looks like for some reason it kind of bugged out on us, so we'll set this value to 1. So now it goes from light to light being put away. So it kind of fades away. And that's kind of us extinguishing it, right? Now, of course, we could make it a little bit more fancy and kind of extinguish it quicker or something like that if we'd like, but we'll just stick with this for now. And then if we come to our flashlight show and we come to the front and we select our Omni light, if we put a keyframe here and then we also put a keyframe here, so that way our energy is set to 0. We'll set our energy to 1. We'll throw a keyframe here, and we'll need to get the value of our flashlight when it's shown, right? And the way we can do that is by going to our flashlight hide, putting this to 0, and then come down to our transform, right click our position, copy our property, go back to our flashlight, go to where we need it to be, and then right click our position, paste it, and then put a keyframe. And that's basically all we need to do to get our animation working. So now all we have to do is go to our code and say, hey, when you use your flashlight, so come in here and just literally say if input.isAction just pressed, and I believe we said the action was, and I will double check because it's been a little bit, flashlight, so that's simple. Flashlight, and we'll say, okay, what if you put out the flashlight, right? First, we need to play our animation. And much like before, we're going to need a Boolean to determine if we're have the flashlight out or not, right? So kind of like with crouching, except for slightly different. So what we'll do is we'll come up to the top, we'll duplicate our is crouched, and we'll put flashlight out, and we'll come down here, and we'll just say if flashlight out, then we can just grab our animator and play. If I remember correctly, it's called, we'll double check real quick, flashlight hide. So flashlight hide. Else we will show our flashlight. Actually, I think it's just called flashlight. There we go. And then all we have to do is flip our Boolean. Now, unlike up here where we did all this fancy logic to set our is crouched to true and false based off of that stuff, we could do that here. We could set it right here. But really, we could just kind of put it down here and just say flashlight out is equal to not flashlight out. Just like that. And that'll flip that Boolean. Now, something to keep in mind that you might see in the industry is something like this. And this is completely valid C# code. So one of the things that I like to teach people is when you see this, it means this next line is tucked under this if statement. Okay, if you had another line under here, like gd.print test, right? This is not part of that if scope, so that's something to keep in mind. If you only have a singular line, then you can get rid of your braces. A lot of times you'll see that in industry, and I'll also show you guys some other stuff in the future of some things that you might see in the industry with C#, but that's something that you might actually see. So be sure to know what that means at least. So now we'll hit Control S. We'll head back to Godot. We will put our flashlight away. Make sure we have that thing put away. And if we hit play, if we hit F, you'll see we now have a flashlight. If we hit F again, it gets put away. Simple enough. Awesome. So really, that's all we need to do to get our character controller, at least the base of our character controller, done. Now, in a future video, we'll build out some more animations. We'll probably change the color of our light and make it dimmer and things like that. Really set the ambience when we start going into our polishing aspects of the game. But in this case, you have a very basic character controller. So in the next video, we're going to create a very basic enemy that we can use for our spooky horror game. And then I'm thinking after that, we might be able to talk about some level design and things like that. So stay tuned for that. But that is all I have for you guys today. So thank you so much again for watching, and I will see you all next time. Thanks.